Okay, start at 9.1 or chapter 9. We're going to be talking about the Pythagorean theorem. This is something that you guys should be well aware of, how to use it. You guys have used it in the past. We're just going to be building on that knowledge today. We're actually going to be starting in GeoGebra, and we're going to be starting right here. This is our right triangle, and this angle here is our right angle. And we're going to be showing why the Pythagorean theorem works. Okay? Everybody should know that the Pythagorean theorem is a squared plus b squared equals c squared, where a is one side, b is the other, and c is the hypotenuse. Okay? But what does the word squared mean? It means to square it. So we took b and a. We'll start at a. And we took it and we made a square. So each side leg is the same. Okay, so this is A, this is A, this is A. We do the same thing with B. We have B, B, E, and B. Okay. What about C? What does C equal? Well, it equals C, C, and C. Well, we said that A squared plus B squared equals C squared. So these shapes inside A and B should be equal to the interior of C. We can solve this just by dragging these shapes in here. So red goes to red, green goes to green, purple to purple, blue to blue, and then yellow to yellow. Oh, not red to red. Yellow to yellow. Okay, that's the Pythagorean theorem, and that's why it works right there. Okay, the squares inside our A and B will fit into our c squared. Down here in exploration 2, we want to consider the triangle shown. Explain why ABC, so triangle ABC, this triangle here, ACD, and CBD are similar. Why are they similar? Well, all of these triangles have at least two congruent angles, right? And that was from chapter 8. We said that if a triangle has, or if we have at least two congruent angles, they're going to be similar shapes. Not going to do part C. We already did number 3. A Pythagorean triple. A Pythagorean triple is a set of 3 numbers positive numbers A, B, and C that satisfy the equation A squared plus B squared equals C squared. And so, like, I think 3, 4, and 5, yep, down here is the Pythagorean triples. Down below. 3, 4, and 5, right? Because 3 squared plus 4 squared should equal 5 squared. 9 plus 16 equals 25. Okay, those are Pythagorean triples. Pythagorean inequalities theorem. We can tell a triangle is either acute, right, or obtuse by using the Pythagorean theorem. If c squared is less than a squared plus b squared, it's going to be acute. If c squared is greater than a squared plus b squared, it's going to be obtuse. One thing we have to check before this, though, however, we have to know that a plus b has to be greater than c. So if this is, if say in this first example here, let's say a is 5, let's say c is 7, and let's say b is 13. Okay, what's 5 plus 7? That'd be 12. Is 12 greater than 13? No, this is actually not a triangle though. Not a triangle. And we have to make sure that those two numbers are greater than C. Down here, we're going to find the value of x and tell whether the side lengths form a Pythagorean triple. Okay, so right here, we're going to say 81 squared plus 108 squared equals x squared. Going to my calculator. I have 81 squared. Oh, it's not on. 81 squared equals 650 or 6561 plus 108 squared. Okay, so I get 1882, or sorry, 18,225. How do I solve for x? I have to take the square root. I get 135. Does this form a Pythagorean triple? Yes, it does, right? 81, 108, and 135. That satisfies the equation, so yes. Check. Number two, we have c squared, which is 8. So we know that x squared plus 4 squared is going to equal 8 squared. So you know that x squared is plus 16 is equal to 64. And if I go on my calculator, 64 minus 16, it equals 48. And the square root of 48 is 6.9. So x is going to be about 6.9. Is this a Pythagorean triple? No, it doesn't really satisfy. But we did solve for x. And they're not nice whole numbers. Number three, we have 15 and 20, so we know that 15 squared plus 20 squared is going to equal x squared. Type it into our calculator. No, I want that one. 225 plus 20 squared equals 625. And the square root of 625 is 25. So x is going to be equal to 25. And yes, it does form a Pythagorean triple. Next, I have 6 and 10, so I know that 36 plus 100 has to equal x squared. The square root, or 136, equals x squared. I have to take the square root. The square root of 136, oops, it's going to be 11.7. So no. Not a Pythagorean triple. And I'll let you guys do 5 and 6 on your own. Down here, from school, you biked 1.2 miles due south. So you biked 1.2 miles. down south. And then 0.5 miles due east. Yeah. Okay. If you had biked home on a street that runs directly diagonal from your school to your house, how many fewer miles would you have biked? So here's our right angle. We're asking how many fewer miles would you have biked? So total, how many miles did you bike so far? Total, we biked 1.2 plus 0.5. We biked 1.7 miles. Okay, so I'm just going to have that right here. Okay, now let's do our math. If we take 1.2 and square it, we get 1.44 plus 0.5 squared. We get 1.69, and we have to take the square root of that. We're going to get 1.3. So this is 1.3. So how many less miles would you have biked? You would have biked 0.4 less miles. Number 8, these last two questions down here. We're going to verify the segment lengths form a triangle. How do we do that? We have to make sure that our two smaller numbers, so 90 and 216, add up and are greater than 234. So 90 plus 216 is going to be 306, and 306 is greater than 234. Okay, so this will form a triangle. But to tell whether it's acute, obtuse, or right, we're going to plug it into our formula. We should say that 90 squared plus 216 squared, okay, that's 54,756. So 54756. Then what's 234 squared? 54,756. Okay. Which means when we get these two angles are equal to each other, what does that mean? It means we have a right triangle. Okay, number 9. We have 1, 1, and the square root of 3. What's the square root of 3? 1.7. So we know that 1 plus 1 is greater than the square root of 3. That's true. Right? 2 is greater than 1.7. But we should know that this 1 squared, well, let's do this quickly. We just did that math. 1 squared plus 1 squared, and then that's going to be equal to 2, right? And is 2 greater than 1.73? Yes, it is. So when that number is greater than 1.73, it is acute. So this is acute.